The water-flogged East Coast is getting hit again with a solid shield of rain. A far-reaching system. It spans more than 1,000 miles from Florida to Maine.
The warning came abruptly, but its urgency was impossible to ignore. Along Florida's once celebrated coastline, a slow-motion catastrophe is beginning to unfold. The U.S. Geological Survey, USGS, has issued an urgent alert, one that underscores how the very ground beneath Florida's paradise beaches is shifting, cracking, and collapsing in ways that scientists have feared for years. From the Panhandle to the Keys, the edges of America's peninsula are eroding into the sea. Not in the distant future, but right now. The sands that once drew millions to bask under the tropical sun are slipping away, and the foundations that once held up luxury condominiums, boardwalks, and coastal highways are showing signs of structural weakness. What was once a postcard-perfect vision of the Sunshine State is rapidly becoming a stark reminder of how fragile coastal life has become. Before we start, hit the like and subscribe buttons for more exclusive news. The USGS warning wasn't born out of sudden panic, but from mounting evidence gathered through years of satellite imaging, soil monitoring, and geological assessments. The agency reported that subsurface layers of limestone, long eaten away by saltwater intrusion, are beginning to cave in. Florida's geology is distinct. It's essentially a porous sponge made of ancient coral and marine deposits. When saltwater infiltrates this limestone base, it dissolves the rock, leaving behind voids that eventually collapse. These collapses create sinkholes, subsidence zones, and even small-scale coastal cave-ins. It's a process that scientists have been tracking for decades, but what's alarming now is the speed of acceleration. The coastline is not only eroding, it's destabilizing at its core. This phenomenon isn't just about losing beachfront property or watching dunes recede. It's about the structural integrity of entire communities that have been built atop this fragile terrain. Satellite data have revealed subtle but measurable shifts in the ground elevation along Florida's coasts. Areas like Miami Beach, Naples, and even the barrier islands near Tampa Bay have shown vertical land motion, a downward drift that suggests the ground itself is compacting or collapsing beneath the pressure of rising seas. The USGS, in collaboration with NASA's Jet Propulsion Laboratory, has confirmed that these changes are not isolated. They're part of a larger pattern stretching across the southeastern United States. Florida, however, stands at the epicenter. Along the Atlantic coast, decades of human engineering have tried to tame nature's power. Seawalls, jetties, and artificial dunes were built to protect million-dollar homes and tourist infrastructure. But these barriers, instead of stopping erosion, often redirected wave energy to neighboring stretches of beach, accelerating their collapse. The USGS report makes it clear: the coastline can no longer be held in place through conventional means. The sea is quite literally undercutting the land. What's even more concerning is that some of the earliest warning signs are occurring in places that were once considered safe. Inland neighborhoods miles from the waterline are seeing ground depressions and sinkhole formations linked to underground erosion caused by seawater infiltration. In South Florida, where freshwater aquifers mingle precariously with encroaching seawater, the collapse is both geological and ecological. The Biscayne Aquifer, which supplies drinking water to millions, sits atop the same limestone foundation that's now being hollowed out. As the coastline weakens, saltwater intrusion worsens, pushing the boundary between salt and fresh water further inland. This process contaminates wells and weakens soil cohesion, creating a feedback loop that further destabilizes the ground. Engineers studying Miami's subsurface conditions have compared it to Swiss cheese, riddled with unseen cavities that could expand with each tidal surge or storm event. The USGS warning is also a wake-up call for coastal planners and developers who have long underestimated the hidden vulnerabilities of Florida's landscape. For decades, building codes focused primarily on wind resistance, given the state's history with hurricanes. But what the report emphasizes is that the greater danger may now be below the surface. A luxury condominium built near the waterline might meet all hurricane safety standards, yet its foundation could be sitting on limestone that is slowly dissolving. Engineers are increasingly concerned that subsurface voids might compromise not just single buildings, but entire districts. The tragic collapse of the Surfside condominium in 2021 while attributed to multiple factors, now looks like a grim prelude to what could happen on a broader scale if the geological instability continues unchecked. Beyond the engineering concerns, there's the matter of Florida's identity, its economy, its environment, and its very existence as a habitable landscape. Coastal tourism is the lifeblood of the state, drawing millions each year to beaches that now stand on borrowed time. The USGS maps show that entire stretches of beach are retreating at rates of several feet per year. In some places, the retreat is far more dramatic after each major storm. The combination of rising sea levels, intensified wave action, and the collapse of underground limestone formations means that these beaches can no longer naturally rebuild. The sand washes away faster than it can be replaced, and artificial nourishment efforts, the dumping of imported sand, are proving increasingly futile. Florida's Gulf Coast tells a similar, if not more dire story. The low-lying marshlands and barrier islands that once acted as natural buffers against storms are fragmenting. As the ground collapses beneath the wetlands, saltwater inundation kills vegetation that anchors the soil. Without those root systems, the land sinks even faster, allowing the sea to rush further inland. The USGS noted in its findings that this self-reinforcing cycle could lead to the loss of thousands of acres of coastline within the next decade. Entire ecosystems, mangroves, seagrass meadows, and coral reefs are at risk of disappearing, taking with them the biodiversity that supports Florida's fisheries and wildlife. The collapse of the coastline also has profound implications for Florida's infrastructure. Highways like A1A and US Route 98, which trace the edges of the coast, are already showing signs of stress. Sections of pavement buckle after heavy rainfalls, bridges show accelerated corrosion from saltwater exposure, and coastal wastewater systems are failing due to infiltration. The USGS findings indicate that as the subsurface voids grow, the stability of these critical transport and utility networks is jeopardized. Cities like St. Petersburg and Fort Lauderdale are scrambling to reassess their infrastructure plans, realizing that traditional maintenance is no longer sufficient. The issue is not simply erosion at the surface, it's the crumbling of the earth beneath it. The urgency of the warning stems not only from the scale of the problem, but from the lack of visible signs until it's too late. Coastal collapses often begin silently, with microscopic fissures forming deep underground. Over time, these fractures widen until they cause sudden failures. Residents describe hearing dull thuds or feeling tremors before parts of the ground cave in. In areas like Key Largo and Cape Sable, small sinkholes have opened overnight, swallowing portions of roads, lawns, and seawalls. The unpredictability adds to the danger. There's no reliable way to forecast when or where the next collapse will happen. What makes Florida's situation particularly precarious is that the same features that make it beautiful, its flat expanses, coral limestone base, and proximity to the sea, also make it uniquely vulnerable. Unlike rocky coastlines that resist erosion, Florida's landscape offers little resistance to the relentless assault of saltwater. The USGS has used advanced radar interferometry to map micro changes in ground elevation, and the resulting imagery paints a sobering picture. Florida's edges are sinking in multiple locations at once. This simultaneous degradation suggests that the collapse isn't confined to one region, but is a systemic problem affecting the state as a whole. The economic implications are staggering. Florida's coastal property market, valued in the trillions, depends on stability and confidence. As word spreads of the USGS findings, insurers are re-evaluating risk models, and some have already begun withdrawing coverage from high-risk coastal zones. Banks and lenders, wary of the potential for catastrophic land failure, are tightening credit for waterfront developments. For homeowners, this means rising premiums, declining property values, and a growing sense of uncertainty about the future. For local governments, it means shrinking tax bases and escalating costs to maintain roads, seawalls, and drainage systems in areas that may soon be untenable. The natural world, too, is responding to the shifts. Along the Everglades coastal fringe, the transition from freshwater marsh to saltwater flat is accelerating. As the limestone collapses, tidal creeks widen, allowing saltwater to penetrate deeper into the wetlands. This kills off sawgrass and other freshwater vegetation, leaving behind barren mudflats where salt-tolerant mangroves take root. While mangroves provide vital ecological benefits, Their expansion into the Everglades signals a profound transformation of Florida's landscape. The USGS has warned that these ecological shifts could alter regional hydrology, changing how water flows through the state and potentially affecting flood patterns far inland. In some regions, the collapse is exposing ancient geological layers never before seen. Coastal bluffs are crumbling, revealing fossilized coral beds that speak to a time when Florida was entirely underwater millions of years ago. Ironically, those same forces that once lifted the peninsula from the sea are now being reversed. The land is, in a sense, returning to the ocean from which it came. This cyclical erosion of geological time underscores how transient human development is in the face of Earth's processes. The buildings, roads, and resorts that now dominate the coast are fleeting compared to the slow, powerful movements of rock, water, and salt. The scientific community is now racing to model how fast the collapse will progress. The USGS, along with state and university researchers, has developed predictive simulations showing that if current trends continue, large portions of Florida's coastline could become structurally unstable within the next 2 decades. These models take into account sea level rise, groundwater depletion, and the chemical breakdown of limestone. The results are deeply concerning. Even in best-case scenarios, Florida's coastline will continue to retreat, and key infrastructure will face increasing risk of subsidence and collapse. At the heart of the issue is the interaction between natural processes and human intervention. For decades, Florida's rapid urbanization has altered the hydrological balance of the state. Canals, drainage systems, and artificial lakes have diverted water flows, drying out some regions while flooding others. The USGS has noted that excessive groundwater extraction for drinking and irrigation exacerbates subsidence by removing the pressure that helps support the porous limestone layers. When that water is replaced by saltwater intrusion, the chemical dissolution accelerates. This process transforms solid rock into a honeycomb of weakness, primed for collapse. The warning also highlights the risk of compounding disasters. As the coastline weakens, storm surges from hurricanes or tropical systems can cause exponentially greater damage. A collapsing shoreline doesn't just erode, it fragments, breaking apart under the weight of water. The USGS simulations show that during extreme weather events, these collapses could amplify wave energy, making storm impacts far more destructive. In essence, the coastline could act like a crumbling seawall, channeling water further inland and magnifying flooding in populated areas. This means that even moderate storms could produce catastrophic outcomes in zones already weakened by geological collapse. Communities along Florida's coast are beginning to confront an unsettling reality. The sense of permanence that once defined coastal living is eroding along with the shoreline itself. Residents report cracks appearing in foundations, tilted piers, and seawalls that seem to lean a little more each year. For many, these are subtle reminders of the unseen processes at work beneath their feet. City engineers are being forced to rethink how to build, or whether to build, in regions where the ground may not hold steady. Some local governments have begun quietly mapping no-build zones based on subsidence data, but such measures often collide with political and economic pressures tied to real estate and tourism. The USGS report represents not just a scientific finding but a turning point in the understanding of coastal resilience. Florida's coastline has always been dynamic, but this is something different. A structural failure of the very landform itself. It's a signal that the natural boundaries between land and sea are shifting more rapidly than human systems can adapt. The warning calls for urgent reevaluation of how society defines and inhabits coastal space. It's not just about fortifying the shore, but recognizing that in some places, retreat may be the only viable option. The collapse of Florida's coastline also serves as a profound case study for the rest of the world. Coastal regions from Louisiana to Bangladesh face similar risks due to subsidence and sea level rise. The USGS findings in Florida could therefore have global implications for understanding how low-lying regions respond to the dual pressures of geology and climate. The data gathered here may shape future policies on coastal zoning, disaster preparedness, and infrastructure design. Scientists emphasize that while erosion is inevitable, collapse is preventable if action is taken early enough to stabilize soils, limit groundwater extraction, and plan development more sustainably. As the ground continues to shift, the cultural and psychological impacts are no less significant. For generations, Florida's coastline has symbolized leisure, freedom, and prosperity, a dreamscape built on sunshine and sand. Now that dream feels fragile. Artists, writers, and residents are documenting the vanishing beaches, turning the slow collapse into both a scientific and emotional narrative of loss. The awareness that entire communities could disappear beneath the tide is reshaping the state's collective identity. The USGS warning, though scientific in nature, reverberates far beyond the lab. It challenges the very notion of what it means to live on the edge of the sea. In the coming years, monitoring will intensify. The USGS is deploying new technologies, including drone-based mapping and underwater sensors, to track the minute-by-minute changes along Florida's coast. The goal is to identify early warning signs before catastrophic collapses occur. These efforts could allow communities to take preemptive action, relocating infrastructure or reinforcing vulnerable areas. But time is limited, and each passing storm season erodes not only land but opportunity. The pace of change is outrunning the pace of response. The collapse isn't uniform, it varies dramatically by region. In the Keys, where the land barely rises above sea level, the risk is most immediate. Saltwater routinely floods streets, and even small shifts in the limestone base can cause localized cave-ins. Along the Atlantic coast, Miami and Fort Lauderdale face compounded risks from urban density and aging infrastructure. On the Gulf side, communities near Apalachicola and Cedar Key are watching their marshlands disintegrate into open water. Each region tells a different story, but all converge on the same theme. The boundary between solid ground and open sea is dissolving. Despite the grim outlook, the USGS warning also provides an opportunity for change, a moment to confront uncomfortable truths. The agency's data offers a blueprint for adaptation, one grounded in science rather than denial. By understanding the mechanisms of collapse, Florida has the potential to pioneer new models of coastal management that other states and nations could follow. Innovations in floating architecture, restored wetlands, and permeable urban design could transform how people coexist with dynamic coastal environments. Yet such transformations require political will, economic investment, and public understanding, three resources as fragile as the coastline itself. At its core, the unfolding crisis along Florida's shore is a story of hubris meeting geology. For decades, the belief that technology could indefinitely defend human settlements from nature's power has shaped policy and development. The USGS warning exposes the limits of that belief. The coastline is not a fixed line on a map. It's a living, shifting boundary shaped by forces far older and stronger than any human enterprise. The collapse now underway is a reminder that the Earth is always moving, and that those who live closest to its edges must learn to move with it. The tremors beneath Florida's coastline are more than geological, they are existential. Each centimeter of ground lost to the sea represents not just a physical shift, but a transformation in the relationship between people and the land they inhabit. The USGS has sounded an alarm that reverberates across every sector of Florida's existence, from its booming real estate to its delicate ecosystems. What was once a story of gradual change has become a crisis unfolding in real time. Every tide, every rainfall, every slight motion of the crust seems to whisper the same truth. The state's margins are slipping away. The coast's collapse is not an event marked by a single moment of disaster, but by 1,000 subtle movements happening simultaneously. The earth does not roar when it gives way, it sighs. The limestone foundation beneath Florida has always been a paradox, both strong and weak. Its ancient coral structure was forged over millennia, layer upon layer of marine life fossilized into rock. Yet because it is porous, it cannot resist the chemistry of saltwater. The ocean's intrusion dissolves it grain by grain. This process, called karstification, is nature's slow undoing, a molecular erosion that transforms solid ground into void. When the weight of modern development, buildings, roads, seawalls presses down upon those voids, collapse becomes inevitable. In regions like Palm Beach County and Broward County, new evidence suggests that some of the world's most expensive waterfront properties are now perched atop unstable geological structures. Engineers conducting subsurface surveys are detecting irregular cavities that stretch beneath entire neighborhoods. These cavities, invisible from above, compromise the stability of foundations. The unsettling truth is that there is no easy way to reinforce ground that is, in essence, melting away beneath salt water. Grouting and deep piling can slow the process, but they cannot stop it entirely. The earth below continues its quiet descent toward the sea. The collapse carries a haunting poetry, the meeting of two ancient forces, time and water. Florida, in many ways, was never meant to be permanent. Its creation was a geological accident, a buildup of marine sediment and coral atop a shallow plateau. Sea level fluctuations over millions of years alternately submerged and revealed the peninsula. Humanity arrived during a brief interlude of stability, mistaking this transient moment for permanence. The USGS data serves as a reminder that the land's patience has run out. The coast is simply reverting to its natural equilibrium, undoing what the last 10,000 years have built. If you liked this video, please give it a like and subscribe to our channel. Also, could you leave your comments below and tell us, what are your thoughts on Florida's coastline starting to collapse rapidly? We want to hear from you. Thank you for watching and see you next time.